Okay, this is the first video in the series to make a review for the common exam, which is next week on May 13th for Chem 8. So you're looking at the top section of the typical periodic table that's used on the common exam. And the reason that we're looking at this is because I need to remind you that um, the periodic table that I normally use instead of using the comprehensive group numbers like that are shown here, where we start with hydrogen over here and then we just literally count up to 8 groups. My periodic tables use the other numbering system. So this is group 1A, this is group 2A, and then this is group 3A, 4A, 5A, 6A, 7A, and then 8A. All right, so I utilize this numbering system for the main group elements, right? It leaves out the transition metals here in the middle. And the reason that I use this other numbering system is because we get the valence electrons directly from the group number. And then those of you that have been with me all year also know that from this group number we get the effective nuclear charge. So this is the first thing. You're going to have a periodic table on the common exam that doesn't list the group numbers out this way. It'll be 1 through 18. You should be flexible and knowledgeable enough to make or understand, for example, that group 17 is group 7A. All right, make sure that you know how to do that. The next thing are the diatomics. And I'm going to list them out here. I have emphasized these things all year long, and throughout the whiteboarding and whatnot that we've done over the course of the year, this is something that at least 50% of you just refuse to know. So I'm going to review this right now, and there's a reason I'm doing it. You really have to know the diatomics in order to write balanced chemical equations, because in any chemical reaction, and I'm going to put that in words in a minute, in any chemical reaction, it's crucial that you use the particular nonmetals that are diatomics in their diatomic form. So this is going to include the element hydrogen, nitrogen, oxygen, and then it's going to be the 7A's, so it's going to be fluorine, chlorine, bromine, and iodine. So make sure that you understand that if you're going to write a chemical equation and it has one of these elements in that equation, when you write that element in its natural form, it has to be as a diatomic. Period, forever and a day, forever and ever and ever. This is absolutely crucial that you understand this. All right, now we're going to practice some synthesis and decomposition reactions. So the first example that we're going to look at is when we have aluminum that is going to be combined with nitrogen in a synthesis reaction. Notice how I'm writing the N2, or the nitrogen. It's diatomic, right? And then we need to determine what product is going to form. Remember, for a synthesis reaction, you have literally 2 reactants that are combining to form a single product. In this case, we're combining aluminum with nitrogen. Aluminum is out of group 3A. Okay, and you should be familiar enough with aluminum. It's one of the triad. You know that when it reacts, it's going to produce Al plus 3. All right, and then the nitrogen, when it ionizes, is going to form N minus 3. Okay, and again, what we're doing here right now, you should realize that how important it is for you to know your elemental ions. You must know your elemental ions. So 5A is always going to ionize to N minus 3. Oxygen's going to go to O minus 2, and fluorine through iodine is going to ionize to -1 anions, which will be the, fluoride, chloride, bromide, iodide. All right, so when we write the rest of this equation, then we can predict, keyword, predict the product as being ALN, right? Because it's going to be Al plus 3, which is combined with N minus 3, so they're going to combine 1 to 1. Now, if I was to write the decomp for this, it's just, it's literally going to be the reverse. So it's going to be ALN, and then an arrow, and then we're going to write in the natural form, not the ionized things. It's going to be aluminum plus N2. This is the decomp, and this was the synthesis here. All right, now let's look at another quick example where let's take a group 1A, something like potassium, and we're going to add that to oxygen, which is O2, right? Because this is a chemical reaction, so you have to use the diatomic. And then what are we going to form? All right, so quickly, you should understand your ions, so you know that K is going to ionize to K plus, and the oxygen is going to be O minus 2 when it ionizes, right? So these guys over here, let me go ahead and put them in our boxes. This is going to be Li plus 1, and then we're going to have Na plus 1, and then we're going to have K plus 1, and the group 2s are going to be Be plus 2, magnesium plus 2 when it ionizes, calcium plus 2, and so on. So coming back to the reaction, we have in its natural form potassium metal plus oxygen in its diatomic form, and then when these two things combine, you should be comfortable with that, we're going to form K2O. All right, and let's see, I'll put it underneath here. So to do the decomp, it's going to be K2O, and then it's going to break down to K, again, plus O2. Now, you should, if you're with me, notice there's a slight problem here. And that problem is we didn't balance this yet. So let's go back to the synthesis. We need 2 of these Ks, right? But when you look at this, you can see, oh no, we have a problem with the products, right? So this balancing here is not correct yet. So what I'm going to do is we'll start instead with the product, and we're going to put a 2 here so that we can equalize out the oxygens. That means we needed 4 Ks. Now that's properly balanced. So we can go downstairs here and fix this particular equation. So now both of these are balanced. All right. Now let's go ahead as another example, and we'll look at the similar situation with a group 2 element. So in this case, let me just draw some lines here so that we're clear on the space. All right. So for this one, we're going to look at, we can take calcium oxide, for example, and we're going to decompose this, and it's going to go to Ca in its natural form. So that's the metal. It's not ionized, and we're going to produce oxygen, which is O2. All right, now take a close look at this, because you can see that the equation is not balanced. All right, and so what I'm going to do is put a 2 out here to start with, right? That gets us back to the right number of oxygens, and then the calcium on the right side of the arrow needs to be balanced, so we'll put a 2 here. And that looks like everything is correct. Now, this is the decomp. So we're going to write the synthesis now. So it's going to be 2 calcium metals plus oxygen in its natural form, which is diatomic, with an arrow, and then we're going to have the 2 CaO. Super, super critical. All right, what do I have to do here? I will write the word critical. Whoops. Critical, if I can manage my spelling this morning. Critical. There we go. Absolutely critical. Okay, and with that, I'm going to close this video, and then we're going to move to a second review.